Hi, I'm Henry, and today I'm introducing Extend, a pair of 21st century handcuffs designed to tackle 21st century problems faced by law enforcement. In Coursework 1, after speaking with police officers, it became clear that they face significant challenges when trying to handcuff larger individuals behind their backs. To manage, they often link two handcuffs together. However, this workaround poses a serious safety risk, as these linked handcuffs could be turned into a weapon against them. Additionally, research revealed that detainees frequently sustain injuries from handcuffs, especially during non-compliant arrests. While minor injuries like bruising and lacerations are common, more serious injuries such as permanent radial nerve damage are surprisingly frequent. Alarmingly, only a small amount of force applied by handcuffs can cause these severe injuries. Based on these findings, a design brief was created with a clear objective: to develop a pair of handcuffs that enhance comfort and safety for detainees by reducing the risk of lacerations and radial nerve damage, while still maintaining the reliability and effectiveness crucial for high-intensity, non-compliant arrests. The new design also needed to incorporate extendability to accommodate individuals of various sizes, particularly those with larger or more muscular physiques. Further research into existing handcuffs revealed that there aren't any suitable solutions for these problems. The current UK rigid handcuffs are very short and low profile, which limits their effectiveness. On the other hand, existing extended handcuffs are too bulky to carry around, and extendable wide cuffs introduce additional dangers for police officers, making them unsuitable for use in the UK. The solution proposed in Coursework 1 was a pair of rigid, extendable handcuffs that could be deployed as needed. The design also incorporated a deployable, inflatable radial nerve cushion, which was intended to protect the radial nerve from damage during non-compliant arrests by cushioning it when the cuffs are applied. The prototyping phase began with developing the inflatable wrist protection. After consulting with a general practitioner, it was determined that the pressure needed to stay under 80 millimeters of mercury of pressure to ensure the inflatable cushion wouldn't restrict blood flow when deployed. Using a blood pressure cuff to test various profiles, some designs were eliminated because they required too much air pressure to inflate. The chosen profile was then tested within the confines of a handcuff arm. In this new environment, even more pressure was required, exceeding the safe limit. Through these prototyping tests, it became clear that applying air pressure after the cuffs are secured, which is the preferred method for police officers, would restrict or cut off blood flow. This insight was crucial in understanding that an inflatable wrist protection is to be used. It must be deployed before the handcuffs are locked around the wrists. A user journey decision tree was used to assess the viability of the inflatable wrist protection during arrests. The results indicated that the design was unworkable because inflating after securing the wrist compromised blood flow, while inflating beforehand delayed deployment and reduced safety for officers. Therefore, it was concluded that inflatable wrist protection isn't viable for this project. Instead, wrist protection must be integrated into the handcuffs and already in place before the arrest occurs. Multiple 3D printed PLA prototypes were created and evaluated through an iterative trial and error process developed with designer critical trials. This method of prototyping ensures that the handcuff's design is refined through each iteration, resulting in high-quality working mechanisms. These prototypes were then presented to a participant for feedback, which was crucial in identifying further design improvements and ensuring the handcuffs would meet the needs of both police officers and detainees. In the user interaction trial with a police officer, these prototypes were tested. The officer highlighted that separate mechanisms for release and retraction were impractical, especially under the stress of an arrest. The single-button approach for both extension and retraction was preferred. Additionally, the trial revealed that the officer unintentionally used the wrong side of the cuffs during a simulation, leading to unintended two-handed use, a critical issue that will need to be addressed in further design iterations. One key insight from these tests was that the inflatable wrist protection needed to be replaced with a more practical solution. The proposed alternative is a durable, cost-effective, recyclable TPU cushion. This cushion would be pre-installed within the handcuffs, providing consistent protection for the radial nerve. It's also easy to clean or replace, making it a practical choice for police use. Another critical change identified during prototyping was the need for a more intuitive mechanism for extending and retracting the handcuffs. Originally, separate mechanisms were considered for these functions, but feedback indicated a single, easy-to-access release button would be more effective. This button would allow officers to extend the handcuffs quickly with one hand during non-compliant arrests, simplifying their use in high-intensity situations. In conclusion, these iterative prototyping methods have been instrumental in refining the Extend cuffs. The changes made, such as replacing the inflatable cushion with a TPU alternative and integrating a single-button release, ensure that the final design will meet the safety and operational needs of police officers while providing enhanced protection for detainees. This is Extend, 21st century handcuffs designed for 21st century problems. Thank you.